What is up? This is a brand new video, and this video is on series, but specifically infinite series. I know it's again another change of pace, but I mean, what else can I write about? Like, what kind of videos can I make, you know? So the problem is the summation from n equals 0 to infinity of x plus 3 to the n plus 2 over n plus 1 times 3 to the n. Alright, that's the problem. So I've just made this up. It doesn't really matter what the numbers are. It's the same idea. This is just still a sub n. So when you do the, I'm going to do the ratio test in this video. Sorry, that's probably the most important thing I should have explained. And the ratio test is, all you do is you take the limit as n approaches infinity of the absolute value of, not just this though, it's a bit complicated, but it's got the word ratio in it, so I'm assuming that you should already know what the word ratio means. So you taking the limit of a sub n, so lim as n approaches infinity of a sub n plus 1 over a sub n. So basically the idea is wherever you see an n in the problem, so n, you just add plus 1. So n plus 2, this is going to be n plus 3. I'll show you it again in a second. And by the way, I forgot that this is the absolute value. So this is the limit as n approaches infinity, dude, of x plus 3 to the n plus 3, because this was n plus 2, now it's n plus 3, over n plus 2 times 3 to the n plus 1 multiplied by the division of the reciprocal, because when you think about it, a sub n is just this term. So if I'm dividing this by this, then I'm just multiplying by the reciprocal fraction. So this is just multiplying, so I'm multiplying by, well, I don't ever think about it. What I say to myself is, right, if this is on the bottom, then that means this must be on the top if I'm multiplying by the reciprocal. So n plus 1 to the times 3 to the n. And then this is divided by what's on the top here, x plus 3 to the n plus 2. So x plus 3 to the n plus 2. Alright, cool. Now what should I do? Well, let's rewrite the limit. It's the limit as n approaches infinity of, what I do to make things a lot easier for myself, I group the terms. So because it's all being multiplied, it still means the same thing if I say x plus 3 to the n plus 3 over x plus 3 to the n plus 2 times. So I just put everything that I think is linked to each other under each other. So I've got 3 to the n on top here, and I've got 3 to the n plus 1 on the bottom here. So 3 to the n plus 1, 3 to the n. Now, one last one. And then my absolute value finishes there. So it's going to be n plus 1 over n plus 2. So what I can do here is basically, if I've got n plus 1 on the bottom here and I've only got n on the top, that means I've got one extra 3 on the bottom because the n's will cancel out. So what I do is, whatever I cancel here, because the limit only depends on n, I can take 1/3 outside the front. So cancel, cancel. This will be 1 over 3. So this will be 1/3 times the limit as n approaches infinity of the absolute value. I'll just give them all room. X plus 3 to the n plus 3 over x plus 3 to the n plus 2. Well, I've got 3 on top and 2 on bottom, which means I've got x plus 3 to the first power on the top and 0 on the bottom. So that's just x plus 3 to the 1 over 1, who gives a crap, doesn't really matter, times n plus 1 over n plus 2. So all I'm doing is I'm just doing a little bit of manipulations here. So now the limit only depends on n, as I said before, so I can take this x plus 3 in front. So this is equal to the absolute value of x plus 3 over 3 times the limit as n approaches infinity of the absolute value of n plus 1 over n plus 2. What is going on? So now the ratio of the coefficients of the highest power term is 1. So this is just times 1. So my answer is x plus 3 over 3, well, the absolute value. And that means that the absolute value of x plus 3 over 3 has to be less than 1 for this to have an open interval of convergence. So it's strictly less than 1, meaning that it's an open interval of convergence. So that means that the absolute value of x plus 3 is strictly less than 3. So now I say to myself, if x is greater than 3, then that means that x is less than 0, or I can say that, so I multiply this whole thing, greater than 3. So it could be greater than 3, sorry. And if that's true, that means negative x minus 3 is greater than 3. That means negative x is greater than 6, or x is greater than 6, negative 6. So now my open interval of convergence is finally negative 6 is less than x is less than 0. That is my open interval of convergence, because I just found out if x was greater than 3 here. And then I multiply the whole thing by negative 1 so I can find out what the other interval of convergence is. And that's the end of the video.